this part. Yeah. um, and the workshops will not be recorded, so just keep that in mind, and you're free to interact, visually if that is useful for you. So yeah, in the next session, so we'll have a set of workshops on RStudio, Visual Studio Code, and Jupyter Lab, on Docker, on doing data analytics and warehousing, and on deploying your own data science applications on the cluster. From 12 to 12:30, then we'll regroup, and we'd just like to hear from you again, how what you thought of this, the event that we have hosted, and to give some general feedback and perhaps some advice to us. And then in the afternoon, it's an open session. So if you want to follow up with your own projects, you want to talk in more detail about the infrastructure, so we'll be available for you to discuss us with. Okay, so I'm joined today with members of the Data Science Research Infrastructure team. So we have Vincent, Binosha, and Rob from the Institute of Data Science, Chris, Marcel, Jordi, Armand, and from ICTS. And we also are supported by Emil and Aryan from Forco Consulting. So at any time, feel free to, and we'll indicate how you can get in touch with us, but these are the members of the team, and we're more than happy to help you out. So our vision for the infrastructure is an effective, scalable, sustainable data science computing infrastructure at Maastricht University. This is a project started in 2018 as a collaboration between the Institute of Data Science and ICTS. And what we mean by that is effective in the sense that the data science research infrastructure can help you get your data science work done with more quickly and with less effort. That it's scalable in the sense that you can use more resources than you would typically have at your own personal disposal, and also that we can grow the cluster when needed through investments by the university and from the community, and sustainable in the sense that this is an infrastructure that would be maintained by the and its community of users. So why is DSRI needed? When we first came, so we started the Institute of Data Science in 2017, and we noticed that there wasn't a centralized computing infrastructure for research. And that's unlike what we've seen or where I have been at both Stanford and Carleton University. And what happens is that then investigators, researchers create their own computing infrastructure, and they're delocalized. So they're often in, small, so closets or under the desk. They're isolated from each other. They're incompatible. They're hard to maintain. And that poses not just a missed opportunity to aggregate these resources and to use more than the sum of the individual parts, but also could be from a regulatory and or from a security perspective also a concern. So what we wanted to do is to create sort of an infrastructure by which people could contribute to this infrastructure for their own research computing needs, but also make this more broadly available to the people who don't necessarily have those resources. It's also, also as important is that it takes a lot of time and effort to maintain computing infrastructure. And we really think that researchers should be able to focus on their research. They should spend time thinking about the computational analyses they want to do, and a lot less time about figuring out how to install packages or keep the infrastructure at the latest with latest patching and so on. And that just takes a lot of time, and you have to devote resources to doing that properly. The university also wants to make research results fair, that is findable, accessible, interoperable, and reusable. And a shared infrastructure of this type would foster best practices amongst us to make sure that we can more easily make our data assets, our research data assets fair, and also to encourage us to have reproducible research practices and workflows. And then finally, a shared infrastructure would enhance the position of the university and help attract and retain talent for data science research. So our design objectives were basically to design an infrastructure that would facilitate large-scale data analysis using the emergent big data technologies that make use of both CPU and GPU computing. They would enable component deployment via containers and primarily the Docker technology, and you'll learn a little bit more about that. that would enable data sharing with flexible and shared storage solutions, reduce the administrative overhead with self-administrative user interfaces. That means that you don't need us necessarily to do a standard data science research. And finally, that it's scalable and fault tolerant by allowing us to globally monitor this infrastructure and to migrate tasks from compute nodes should they fail or that we need more capacity. Okay, and then I'll ask Marcel.
Yes, so what we have now is basically a pretty much automated infrastructure. We'll get to the specifics of the infrastructure later, but we found a solution in Red Hat Openshift. We use the upstream version of Openshift, which is OKD, which is supported by the community, basically. We're currently moving to a different storage platform. So we previously used MapR storage and are now moving towards a Ceph-based storage, which integrates in a nice way with OpenShift. OpenShift is built on top of Kubernetes. So with OpenShift, we have a management interface for Kubernetes. And with Kubernetes, we can run containers that are according to the Open Containers Initiative standards. So, next slide, please. So why containers? Containers contain basically everything to everything you need to deploy an application. Everything is contained in the container, and it allows for portability. So what you can do, you can build a container on your own computer and then port that container towards the DSRI infrastructure. And this way, it allows you to scale easily. In the workshop, one of the workshops later, we will show you how to deploy your own containers on DSRI. So next slide. And yeah, for the hardware, we currently have 16 CPU nodes in the cluster with AMD EPYC processors and 512 gigabytes of memory. For storage, we have about 120 terabytes per node, which results in almost 2 petabytes of storage. And we have a GPU node with 8 graphics chips. There are NVIDIA Tesla V100 chips with 32 gigabytes of memory. And all the nodes are, pretty much all the nodes are connected with 40 gigabits per second network interfaces.
This schema, this diagram shows you how more the user point of view to use the DSRI. So instead of looking into the technical, so this is basically what you would do, what you will do when you will be using the DSRI. So usually you will go to the OpenShift web UI that we will present you to start an application. This will allow them to deploy your application in a Docker container in one of the nodes. The node will be chosen automatically by DSRI. The only part that is a bit tricky to catch is actually the fact that computing and storage are stored in a different place. So in your Docker container, there will be typically one place where you can put that is linked to the storage. So for example, if you start RStudio, your files need to be in home RStudio because this is this folder and all these subfolder that have been linked to the persistent volume. You can also attach. What is cool is that you can then attach also multiple volumes to the same storage. So for example, you can have a RStudio that will also be able to connect to the data that you use for your custom app or your Visual Studio Code. And usually you will access application from their web UIs, like RStudio web UI or Jupyter Lab web UI, but you can also use the terminal for more advanced operation or containers that does not provide a web UI. So what can be done currently? Like Marcel said, you can start any Docker container, but we also prepared some popular data science template that you can basically then, it's an application you can deploy through the web UI in literally 5 clicks, and you only need to provide the password. We have Jupyter Lab, so you can use any flavor of the official Jupyter Docker stack. RStudio, Visual Studio Code server, so it's basically your favorite IDE, but directly in the browser, and it's quite fast actually. TensorFlow on or PyTorch on our GPU nodes, and then you have also a lot of graph database, not just database, SQL, NoSQL, graph, and we have also some distributed parallel computing tools like Apache Flink or Spark. Yep. Next slide. So all of this seems really nice. So basically, it seems like you can just find a Docker image for any data science application you want, and you can just start it. The reality is that there are still some caveats behind. So it's not that easy. First, you are deploying an application that is accessible from the web. So it's still within UMNet, but anyone can connect to Eduroam at Maastricht University and then access your application if it's not properly protected. So use good passwords. I want applications that are exposing the web console without login that will allow for people to execute scripts directly in your project and then get all the data, your precious data. So with great security comes extra configuration. We chose Openshift because it comes with additional security, which also then comes with a slight bit of extra config. You cannot just say, for most Docker container, you cannot just say, start this on DSRI. You will need maybe at least, to say to Openshift that you authorize this container to run with root, with sudo privilege, for example. And for really complex app, like complex database or Rabbit, things like that are passing messages and doing things on the network or the storage, you might need even more tuning. And in the end, also everything is on the DSRI servers, not your laptop. So it's a good thing, and sometimes it can be a bit painful when you just want to test something quick and you don't have a good internet connection. But on the long run, also it's much nicer because then it's more sustainable, and so it will require you to learn a little bit about how handling things on the server instead of directly your local laptop. And next slide.
Thank you, Vincent. So now I'll go to some of the changes of the DSRI with the integration of OKD 4.6. So with the OKD 4.6, one of the main changes that you can see is the new and improved user interface, mainly in the Openshift container platform web console. It provides 2 different perspectives for the users. These perspectives are the administrator and the developer perspective. So the developer perspective provides workflow that are specific to the developer use case, such as creating and developing applications on the Openshift container platform by importing existing code base and images and the Docker file. So secondly, visually interacting with applications, components, and services associated with them within a project and monitor their development and build status. Grouping components within the application and connect them within the across the application also possible within this developer perspective workflow. So if I move into the administrative perspective, it provides a workflow specific to the use case, such as the ability to create a persistent storage and network information. And it should be improvised, and even though it is called an administrative perspective, the use case provided in this are user-specific administrative tasks and not related to the DSRI administration. So sometimes I got questions from some users as to why there is an administrator tab on my view. So I just wanted to highlight this. So moving on. This is the new user interface for the Openshift web application. So as you can see, there are various different options available to the user to create an application in the DSRI, such as from the container image, a Docker file, YAML files, and existing template, etc. So, however, there are also options of using a terminal window to do the same task, and in some cases, using the terminal is better, especially when it's come to the operations like loading large data sets. This will be depend on the person. So if we move to the next slide, now let's go through how you can easily deploy application on DSRI using a template. First, find a template to deploy to your data science application. If you need new templates, please don't hesitate to contact our team. Second, afterwards, provide a few parameters to start the application, such as name, password, and the storage location, and then click create, and that's it. So now you can access your deployed application through its web UI. So if I move to the next slide, yes, there are alternatives. You can customize and define your application development as well. DSRI supports the deployment of any Docker image with a little configuration from your side. Very briefly, you will need to create some YAML files to define how to deploy your application by providing information such as a port, storage requirements, and resource limitation. Additionally, DSRI also support the use of operators from the operator framework as well as the Helm. So you can contact us if you need any help regarding writing these YAML files. So next slide. Now let's talk about different storage solutions provided by the DSRI. As a user, you can use two different storages types when running services on the DSRI. First, ephemeral storage. This storage is always bound to the pod and data will be lost when the pod is deleted. But this deployment does not require the creation of persistent storage, and it is faster to test the code. When creating pod, Openshift will as default use ephemeral storage. It creates volumes bound to the pod. Second, persistent storage. With this storage, the data will not be lost when the pod gets restarted. This is the same case when it's come to the dynamic storage as well. This storage will be automatically created when deploying applications with the root access. This is a new feature of our OKD 4.6. Move on. So I will go through some of the advantages of using the DSRI. So you can run your work on remote server at through popular web UI as a Jupyter Notebook, RStudio, Visual Studio Code instead of your local computer. And in turn, this allows you to get very fast results. Moreover, you will be able to make use of best practices using Git to version and shared code and provide shared environments or container to improve project fairness. Finally, you can use DSRI to easily develop and share these results with your collaborators. So in next slide, there is a comprehensive documentation if you need any help on the DSRI, which is available in the link that you can see in here. It includes all the necessary guides that you need to get started with the DSRI step by step. You can find small videos also and the comprehensive documentation as well. So if I talk about our communication platform in the next slide, we use Slack as the official communication platform for the DSRI, where we maintain a separate channel called Help Desk, where we help the users with their project issues and also guide them if and when necessary. There is a public repository for the DSRI that you can access by going into the GitHub at the following location. Also, the public roadmap for the DSRI has been published with our future plan for it. So moving on, at the moment, we have 117 registered users and 62 plus documented projects. Vincent?
Yeah, I can share my screen, I guess. Yeah. So we'll show you quickly how DSRI can be used to start an application. Here you can see a bit the final the final stage of what you can get on the DSRI project by starting a lot of different data science application. This is actually all integrated within one platform, so it's quite easy to deploy and connect. But here I will show you just how to start a RStudio application. So I will create a new project for this, call it Test Vincent. Yeah. Okay, now it's created. I actually doing this with a regular user, like it's not an admin user or anything. So I have exactly the same right as you would have on the DSRI. So here now I have a project. I'm in my Test Vincent project, and I would like to add an application. I have a lot of different choices. Using the catalog is the easiest if you just want to get started with those popular applications that we predefined. But if you want to build, you can also build from a Docker file or directly from container image, on Docker Hub, or even from code in a Git repository. And so in this case, we'll check the catalog. So we're looking for a template. So you will need to have the template checked, and here you can see we have a lot of things that are available. Most of them should work because a lot of them are provided by Red Hat, but it's not 100% sure they will work. They might need a bit of tweaking. If it's provided by an Institute of Data Science at UM, then normally it's ours. So you can find things like RStudio or JupyterLab or Visual Studio Code, And so we'll be interested in RStudio. Let's start RStudio. It will start it in my namespace. I will leave RStudio as name. Use a password that is hard to find, but easy to remember. And for RStudio, we have also this additional parameter to set up the number of threads for OpenBlast that can be helpful to optimize your application depending on what you want to do. And for the Docker image, we are using a Docker image that we host directly on GitHub container registry to avoid issue related to the Docker Hub container limitation, the Docker Hub registry limitation. But you could use anything that is based on Rocker, which is, if you're using RStudio, you should know that it's one of the most popular distribution of RStudio out there. And so you just need to hit create and wait for this to start. You can check, so if you click on the pod, you can check in monitoring, will it be fast enough? You can see the events that are going through. So it's creating a lot of objects. The advantage of the developer view is that it's hiding all this complexity that is really usually more focused for administrator directly in the administrator view. So usually don't go to the administrator view. Check out this nice graph. You can check the monitoring. And so here normally you will have CPU usage, memory usage, bandwidth. Most of them works pretty well. You can search for the different objects in your project. You can see also here the detail of your project. Change, for example, add access to some people. And you can see also the different objects that are there. And it will also warn you if some objects are just doing bad things. And now all I do is go here. It was written in the description, but the username is RStudio and the password is the one that I provided. And now I'm connected to RStudio. 1 + 1 + 2, 3. You can access the terminal. You see you're in home RStudio. You can install anything, but you will need to use sudo. But you have sudo access normally, exactly. And one thing that can be interesting now, let's touch something. I will create a file here. Actually, you can also upload using the usual, RStudio thing. And this file is actually stored in this storage that has been created automatically for RStudio. So now when you create another application, you can add, connect the new application to the storage and access this RStudio storage. And if you delete the application, the storage will still be there. So you can even just restart the application and connect to the right storage, and you will get your data will be still there. And that's all. Here it's quite simple, but one thing that is nice is then you can add any databases, do something like this, and create the database by just providing basic stuff, like the service name. So this is how you will use how you will connect. You just need to call PostgreSQL, because everything that has been deployed in your project can be reached from within your project easily with the service name. And so then you can easily deploy databases and just connect to them to do data analytics. I think that will be all. And next step will be Luc's presentation.
Hi, Vincent.
Hi.
Hello, participants. Good morning. Let me see if I can.
Luke, did you want to share your slides, or do you want me to share the slides that we have?
Do you have the text where the switch points are? No? Okay, fine. Thank you. I'll give you an indication.
Okay.
Good morning, participants. I've been invited by the DSRI team to give a short talk on using the DSRI pre and post version 4 upgrade from a user point of view. And in this respect, I'm a typical user because I joined the Big Cat Informatics department in May of last year. And I learned that we had access to this advanced computing platform that is called the DSRI. And the bioinformatics department wanted to use that as the preferred in-house computing platform. That was our goal. We want to do bioinformatics related high performance programming and analysis. And a lot of the tools that we will be using have been just displayed by Vincent on the. So, next slide, please. Yes, the requirements. To achieve our goal, we need to have a platform that is stable, and our users must be able to deploy their applications in an easy way, and it must be easily manageable. It must be reliable, it must be repeatable, and it must be secure. Next slide. So I got started in the version 3 era, and I'm fast forwarding a little bit now because I had to learn a lot. And to get an application started got me hitting the proverbial wall. I tried to start an application. I requested the disk space because that's one of the first things you have to do. And I waited for it to be assigned. And I waited some more until I realized it was hung in a pending mode and nothing was happening. So assuming that I probably did something wrong, I tried to cancel everything so I could restart my attempt. That got me even more trouble, as the cancel of the disk space allocation request now was also hanging indefinitely. So I involved Vincent and said, Vincent, what am I doing wrong here? And he found that I had requested too little disk space to be allocated. And so the allocator just did not want to grant a request and left the request hanging active. Now, Vincent, expert as he is, deleted all the pending requests and made me a disk space allocation available to play with. So attempt 2 was a simpler version. I tried to use a standard catalog application and get that started. But again, things were not working properly as the apps could not be found in the App Store. I simply couldn't get them to work. It said, well, not found, not available, all sorts of problems. So as a last attempt, I decided to make a simple application using the guides on the documentation pages. And with the space allocator now working, I finally got my app working. However, I started to realize that using the version 3 DSRI was not as easy to use as I had hoped for. A lot of very specialist knowledge was necessary to manage the things, and we as Big Cat users simply did not have the time to become as expert as Vincent or Binocha in using the DSRI on a systems level. We just wanted to use the thing to run our applications. At that time, Vincent was referring more and more to an upcoming upgrade to version 4. From what I could find on the internet, this was a major upgrade and it would be much easier to use, thanks to a redesigned user interface that incorporated many improvements based on user feedback from the community. So I decided to stop and wait for version 4. And we go to the next slide, because now we are getting at the restart in the version 4 era. It turns out that that was a good decision. Early February of this year, the DSRI team invited me to give the new version 4 user interface a try. That second encounter was really a nice surprise indeed. The user interface is far more user-friendly, as you have been shown by Vincent in the previous presentation. And the disk space allocator is now working and using default values and auto-assigning space and there is a lot less to think about when setting up an application. More important to me, and most important to me, the application store works with images available at the click of a button this time. Great. So I created my first 2 MySQL applications and tested if I could access them both ways using the MySQL command line interface, going from one app to the other. That worked first time. Now, this was a good user experience. The only caveat is that when I used my laptop to access the applications from outside the DSRI, it has to be done using port forwarding due to firewall restrictions. I could not secure shell straight into the application that I created. You have to go use the Openshift console, and the Openshift console works as a VPN tunnel, and it forwards the ports to the from the outside world, being my laptop, to the inside application on the DSRI. Once I got that figured out, that worked great. Even tunneling the MySQL ports made the databases accessible from my laptop using the MySQL workbench. No problem whatsoever. Slide, please. So our current status is that in the meantime, a few of my colleagues from the Big Cat department have also started using the DSRI. And it is with pleasure that I can announce that the DSRI version 4 is a much more user-friendly platform for our department to use. Our users are looking forward to using the DSRI version 4 platform to do further science research, where the DSRI will play a much more important role in the very near future. Slide, please. And as a final slide, I would like to thank the DSRI team for their continued support. And I wish the team a lot of success with the deployment of the DSRI in the near future. The Big Cat team really appreciates their effort to continue to develop the DSRI platform. And we are really looking forward to start using it for the advanced goals that we have set ourselves in providing a platform that is easily manageable and expandable to our growing needs. Thank you very much.
Thank you so much, Luc. Thanks for sharing your experience with us, and I think it goes to show just how far we've come from when we first started with a great ambition, but a really limited tooling. And indeed, we're as pleased as you are that the underlying software infrastructure that we use, the OKD platform, is evolving, has huge community support, and that we're able to provide it to you and the other users. So we're also really, really excited about that. Thank you so much.
You're welcome. And thanks for your effort again. It shows the documentation is far better. The system itself is much more manageable from a user point of view. And it's an extremely large upgrade, community driven from version 3 to 4. And thanks guys for installing it. It was much needed and it pays off at this time. Thank you.
Thank you so much. Okay, so so we obviously have been, working on this for years, and we have many more years of work to do still. At the moment, I think what you can see is that we have this growing community of users. Our interactions are, open and transparent. We have, we have our Slack teams to have those discussions. We have weekly technical meetings in which we can also invite you to participate and to discuss what your, what perhaps major feature requests are. And we also have monthly planning meetings and strategy meetings where we think about the future and how we're going to position for it. We have set up an advisory board to gain feedback from, and they're very helpful to help us think about our priorities. We run these community meetings now. This is the second one, and we hope to basically do this, basically about 3 or so per year, where we can give you updates on where we stand, to give you to enable people to share their experiences and what they're trying to use the DSRI for, and also to onboard new users through a set of training workshops. We've been working on improving the user experience, and indeed the documentation is a major part of that, and we're really proud of the quality of the documentation that we have made available. Basically, every interaction that we have where a user has some kind of challenge, we try to record that and make it part of our documentation so that other people can discover those pitfalls and can overcome them very quickly. We do hope to create more kinds of documentation than just the what you see on the website, textual. We want to create, for instance, videos and then sort of like snippets of how to get things done. So we'll be working on that. And in general, you have access to our team. I would call it a Monday to Friday user support team. So happy to engage with you on your projects and provide advice and support in that way. We have a mailing list and also the issue trackers that internally that we use. On the infrastructure side, you heard a lot about this new version of OKD that we're using. And so we have this set up on a subset of the cluster. Obviously, our goal is to transition from the 3.11 cluster to the 4.6 cluster. And we'd like to be able to do this in the next couple months. So we'll be reaching out to users that have been using 3.11 and to try to migrate them. And there's a session today a bit about that. Other big parts of our work is to think about how we can better schedule the resource requests. And this, I think, is quite pertinent to, for instance, the GPU computing. As we saw, we only have a limited number of GPU units. What we do right now is we assign this on a per project basis. And we want to move to a more dynamic allocation model. So this requires us to add more kinds of monitoring and resource management tooling to the infrastructure, which we feel confident we'll be able to do over the next period. We're also really looking at security, data protection, and disaster recovery policies and plans. For instance, at the moment, we're looking at, or we're trying to get GDPR certification for the DSRI. We're going to come up with guidelines and for users in how they should manage sensitive data on when they're computing with it on the infrastructure and these kinds of things, so that we can tackle sensitive data analyses, storage, and management. A big part of what we're doing is also bringing new applications to the new platform, to the 4.6 platform. These are infrastructures like Open Data Hub and Kubeflow, and they are packaged or managed, software packages for data science research that have been put together by data scientists, and just basically expand what we can do with that infrastructure. So that's possible now, but requires some configuration, and we hope that we'll be able to announce these things and to invite users to try to make use of it, for us to document this and to encourage others to use it as well. In general, sort of behind the scenes, we're developing community-based governance and other policies around usage, policies around community-based investments, about securing long-term financing, and to also procure external funding that would both sustain the current infrastructure and potentially expand it in new directions. Okay, so that marks the end of our formal presentation, I believe. So this is a good time that if you have some questions, then we can pick them up. And again, I encourage you to post in the chat your questions, and then we can pick them up there. So let's see, I see questions from Orly. Orly, would you be interested in asking your questions, or shall I do it?
Okay, I'm happy to do it. I was forcefully muted. So the first question regards a bit. It was also mentioned on the slides, that of course your data needs to be uploaded because it needs to be in the container. I might be not using the correct word, so please correct me. But I was wondering, is there any restrictions? Because if I think about some of the research that is done on Merlin, we have really quite big data sets. So if all those data need to be uploaded, I can imagine that there might be some restrictions. I'm not sure. And also we are thinking of, for example, storing our imaging data on Omero, which is again a dedicated way of doing this, and Timo is also in the audience, so he can maybe explain this better. But again, that's just a question whether we could then link from there to the server, because that would of course be very convenient.
Okay.
Yeah, usually. So the classic way to upload really large data on the DSRI would be to use the Openshift command line tool, which is basically doing like a SCP. You're just uploading the data through the network connection. And so the thing here, for example, you will need also to make sure that you have access to the different network, because also since the hack last year, there are much more limitations on the network itself. So maybe, for example, the DSRI originally at the start could not connect with GitLab. So it could connect with GitHub, which was on Microsoft servers, but due to the networking limitation that have been put in place, it could not connect to GitLab, which was a bit ironic since it's on our own infrastructure. So usually all we need is to contact the networking people with this. Then for linking with a data server, usually the question is how does this data server allow people to link to it? Because what you have here is just a server. It's like you have an Ubuntu computer that is on the internet, and you can do whatever you want. You have root access, so you can install anything. So usually Omero, for example, let's take this example, they should provide maybe, I don't know, a way to connect to it and to get the data. So they should provide something to give you an API key, for example, then that you can save in the container, or using a secret, for example, or a Python library that should allow to connect, like S3 storage. So usually the question is, do the storage people, storage server, do they give a tool to connect to it, and can I connect to their URL through the DSRI? And if you cannot, we can contact networking. Otherwise, really, if you have the data on your laptop, it will be installing OpenShift OC client and just running it. The top, if you come at UM and you plug it with Ethernet and you let it run for 1 or 2 days. Usually it's quite stable if your connection is stable, so it should upload everything. On the limitation again of the storage, there are not really complete limitation at the moment. You just can, I'm not sure of this, but I think you can ask a storage that is like 10 terabytes, because at the moment really storage is not the problem. Also DSRI is not expected to work as really primarily storage source. So yeah, it could be nice, if we can find. Also, feel free also to contact us if you have any question about improving the process with the tools that we have, because then we could implement it in the documentation to say, okay, if you want to upload your thing to DataHub. So I think there is a question to DataHub. We'll also answer it at the same time. But yeah, if you want to upload your thing to DataHub, you just need to install the DataHub Python client, provide the API key that you get in the option of DataHub, and then run this through Python this way, and everything will be loaded in 2 hours.
I would like to add one more thing. If you want to link with another data source, usually if you want to work with the data, it's best to have the data locally. So it kind of depends on what you want to do with the data, but in a lot of cases, I think you want to make a copy of the data towards DSRI and then work with the data. But it really depends on the use case. So we have to look a bit further into the specific use case to give you the best advice.
In my case, actually, I had a really large data on a server at IDS, which is basically a server that is outside of the DSRI, but within UMNet, a large server where we publish our services, public services. And I just installed the OC client, and I did the OCCP in the background. I leave the terminal, like with no hub, something like this. I just did OCCP running in the background, and it did, I copy everything quite quickly over the network. So if you can just install OC and use this. Actually, this would be the best the best way.
Okay, thank you, Vincent. Thank you, Marcel. Aurélie, does that answer your question?
Okay. Yes. Okay. Does it work? Yeah.
Yes.
Yeah, it answered my question. Yeah, I'm sorry. I have a very short follow-up question. Actually unrelated, but also important. I think I was wondering about financing, and this is of course very practical, but how does this work? Like, what is the finance model for the moment? Because this is of course a great infrastructure, but obviously a lot of time has also spent on this. So who is paying for this, and also the users? How is this done, and how will this be done in the future as well?
Yeah, good question. So at the moment, so the DSRI was initially funded through the iBoard, a major core investment there to procure the GPU unit and a core set of the cluster nodes. But we've also had contributions from other research groups, such as MaxBio, and so what we would like to do, what we're currently doing, is we have funding from iBoard to support the technical team, and we are making a request now, actually this month, to get more permanent funding for the project, both in terms of staff and equipment. So that should, if successful, that would provide us with this base of operations that we could rely on. Our goal, from my perspective, is to have DSRI a non-user fee infrastructure. It's something that should be accessible to anybody who wants to use it. Perhaps as the use of the cluster grows, then what we'll have to do is think about how to prioritize or how to schedule or queue up resource requests. And so our hope is that research groups that procure their own research funding, in which they have an equipment component to that, will make a direct investment into DSRI and have prioritized access to the infrastructure that they procure specifically. And when it's not used by them, it's accessible to the rest of the community. So that's the general governance policy that we have, that we intend to implement. But at the moment, we're nowhere near the maximum usage of the infrastructure. So there's no, there was, I think, also a question about sort of queuing and that sort of thing. It's only with the GPU units where there needs to be pre-allocation to the projects. So you need to make a request for the GPU resource, and then we can allocate that on a per project basis. So yeah, this is very much a topic of active discussion, is what is going to be the business plan or the sustainability plan from for the DSRI, but that I gave you the general outlines of what we're aiming for. Okay, thank you.
There is one about RStudio. I guess one needs to use the Docker RStudio server container. I'm not sure about which container you're talking about, but yeah, there are multiple ways to deploy RStudio. And normally you can just deploy any Docker container. And the only thing is, if the template that we built is built for RStudio Rocker, the Rocker distribution, which is basically a construction of R and Docker, Rocker, quite smart. And which is, I think, one of the most popular, and then you can install anything on top of this. So we recommend just to use this one, but if you want to start any other Docker RStudio container, you might just need like to change the port or the storage to do inside.
And if I add top of to Vincent's answer, actually we have already a template for the RStudio, so you can directly try that RStudio as well. It has root permission, so you can do all your root access to your work.
Yeah, then you can install anything.
Yeah.
Okay, thank you. Just to follow up also on my comment, I wanted to indicate that, so we've had investments by Big Cat, by MaxBio, by SBE, and also from Master Clinic. So again, I think if you're a research group and you have computing funding, or you've procured funding for compute infrastructure, then we're happy to discuss with you how to make that investment, how to put that into the DSRI, and the conditions that would go with that. Okay, let's see. So then I see a bunch of questions also about sensitive data from Niels and also from Freddie. So thank you for those questions. This is the active area of our current investigation, is to exactly figure out what are the rules and regulations around storage and processing of sensitive data. And we want to do this in the correct manner. So we're consulting with our ICTS colleagues, with the data protection officer, with the information managers at the university, and to come up with indeed what the correct policies are going to be for DSRI. Once all of these things are understood, we will of course document these, and then we hope to have a seminar about processing sensitive data on DSRI, so that we make it very clear how to do it correctly, what, if any, reporting are required, all these things. We really want to make sure we do it correctly. So for the moment, we advise you not to use sensitive data on the DSRI, except if you really know what you're doing, and you've done this kind of computing before, and you know how to take the necessary precautions. But for the moment, it's not something we actively support until we figure this out. But we definitely want to do it, and we think that's going to be a major use case for DSRI, indeed. Thank you for the questions. Okay, so let's see, we have a question from Zahir. So maybe I can read it out here. So it says, thank you so much for this presentation. I am a PhD student, Department of Methodology and Statistics at Maastricht University. I'm looking for high performance computing service. Can I avail your services? Yes, so of course you can. Moreover, it is requested you explain from scratch. Okay, I mean to say how I transfer my R files to your system and how I run my simulations, and last but not least, how I collect my results. Yeah, so of course, so welcome, Zahir. We're happy that you're here and asking these questions. In the next session, we're going to have an introduction or tutorial about using these kinds of tools like RStudio. So I encourage you to join that workshop session so you can better understand how all of this works, and also that those specific questions can be answered there and you can see it in action. Okay, let's see. What else do we got here?
Queuing policy. There are two questions that seems to have some interest about. So the first question was from Aurélie again. What is the current use of DSRI versus capacity? Is there a waiting line? And if so, do you get an idea when it will be run or done? And the answer is no. It's the Kubernetes have not been built as a batch scheduling services. And how we use it currently is basically a search service. So you arrive on the server and you start your RStudio, and by default, we will allocate as much resources as you need and as it's possible. So usually it means that your application will get evicted if you're trying to take more than half of the complete node of the server on which it is running. So if you're if you want to have too much, then you might be just evicted. So your code will just restart, you will not lose the data that is in the persistent storage, but you will lose the workload that have been running currently. This can be improved in a way that, so currently we expect this. If you really want to have much more than half of the node, because you were expecting to require a lot of resources, we can provide defined hard-coded limitation to make sure, basically to give you all of a node, but then no one else will be able to schedule anything on this node. And so the use of Kubernetes for especially data science and high computing workload is more and more developed. And there are some service now, like system that allows to do it, like Volcano, for example, which is a batch scheduling system for Kubernetes, which then would allow us to set up some batch scheduling. But for the moment, the idea was really to have a self-serving platform. And we will see and try to make it evolve with the use when we will really need it. Maybe Marcel and STS are over element of answers.
Okay, maybe we can, we'll end our questioning here so that we can turn our attention to the workshop. So we have 4 workshops for you. So one will be on RStudio, Visual Studio Code, Jupyter Lab, how to start up these software, how to connect to storage, and also to discuss the data migration from the old cluster to this new cluster. So the demo will be on the new one. The second one is on a Docker workshop, so building a Docker image for your application. So Docker is the principal mechanism that we will deploy applications on this cluster. So it's very useful. If you don't already see the package through the set of operators that are there that you want to launch, then you might want to create your own. So this is a workshop on how to build your own Docker image and deploy it. The third one will be on data analytics and warehousing, and then the sort of a demonstration of using the cluster for doing some data science research, and then finally to deploy new data science applications on the cluster, and to work with these Kubernetes clusters. So I guess Binocha, it's supposed that you wanted to maybe organize us for these the workshops.
Yeah, now our workshop breakout sessions are all open. You can join for the workshops. These are the options which we have. Docker workshop, this will be, Marcel will be talk about the build and deploy an application from a customer Docker file on the DSRI. This will be specifically on the how to deploy it on the DSRI. So start an application on the DSRI. In this workshop, I'll discuss about the RStudio, Jupyter Lab, VS Code. This will be focus on the beginner level. So if anyone needs more information, what are we doing and how you can deploy those templates, so you can join for that. And using the DSRI for data analytics, we have Pedro from IDS. So he will discuss about regarding this topic. He will present the example of how the DSRI can be used to perform data analytics, deploy in Jupyter Lab, Postgres SQL and database, and the Pongo database as well. So finally, Vincent will discuss about the potential platforms for the science. He will explain more into the who has a little bit knowledge about the DSRI and the data science applications. Okay, these are the options. So you can join for the breakout sessions.
Yeah, the last one will be more of a discussion, yeah, than a workshop. So if you come, yeah, we expect you to feel free to talk, and because the goal is to try to see which kind of solution will fit well for people at UM. There are some questions about if people want to change workshops. So I guess we can do it directly through the chat, or they can contact you.
Actually, breakout sessions are all open, so users can join for the breakout session by themselves. If you have technical issues, let me know, then I can assign you for the breakout session.